for programming Minecraft. Hello everybody, my name is Quarter Neon and I'm currently a freshman in college. I'm majoring in software engineering, and in this video I'm going to be using the OpenGL library in C++ in order to program Minecraft. And I'll also be using GLFW in the OpenGL mathematics library, because otherwise this would be basically impossible without both of those. But other than that, this video is greatly inspired by this other YouTuber I used to watch when I was around 12 or 13-ish, who also made Minecraft, and I will be following in his footsteps. And if you want to join me, that's fine. Thank you.
So my first implementation of this was laughably terrible. It looks like I'm programming this in Microsoft PowerPoint, but the good news is that nothing inside the chunk is being rendered, which saves processing power and is optimized, and chunks are being loaded, for one, and textures are being loaded, for two, which that is a win. So my next implementation of this goes quite a bit smoothly, and that's because originally I was using batch rendering, which for some reason is slower than what I'm using now, which is storing every single indice and array buffer inside of the chunk separately. So since I'm doing that, it also means that I can load and unload these chunks very fast and wherever I want. I.e. this hole in the middle of the map is actually a really good thing because it sort of showcases that design. So then all you have to do is just replace your list with a hash map, and when you do that, you pretty much just have an infinite world. It literally does work like that. So what I'm doing here more specifically is whenever the player moves over to a new chunk, i.e. whenever the player's position divisible by 16, and then you floor that number. Whenever that number changes, then the player has moved over to a new chunk, and then you generate a new chunk.
And as for the stupid annoying chunk boundaries, literally all you do is just get whether the chunk exists for the block near the edge of the chunk. For example, if I was on the x-axis, I would check if x plus 1 of the next chunk over has not an error block.
So then the next thing that we can do, since we have all of these features, is, well, we just change where the top Y layer of the block goes. And here I'm just mapping sine and cosine on the X and Y axes, and we get this sort of cool sinusoidal wave. And you can also play around with this and reset the chunks every single frame to get this cool wave effect. And if you look at the side of the chunks, it's literally just all grass, so it was time to implement new blocks. And believe it or not, everything up till now was not that bad, but this was pretty bad. Basically, you store blocks inside of an enumerator type called dirt, but then you have to organize the blocks to a certain integer map, and then you call that integer from an atlas class of textures, and then you decide which texture of block you want to put on one of the 6 sides of the block in the game. So then the next thing to do was, well, going chunk by chunk and generating the chunks that the player stands in is not a very efficient way for chunk rendering, so instead it was to generate a list of chunks around the player. And like all first implementations, the first one usually goes really badly and chaotic, and you might be able to see what I'm doing here and what my mistake is. My mistake is that I'm just generating a grid, and what you actually need to do is generate around, not just around, but around. In other words, instead of going line by line, we want to be symmetrical on all sides. In other words, it should look more like a spiral. Although this is not the exact solution I used, it's pretty close to it. And now we also have this other problem where chunk optimization is not working at chunk borders anymore. So, yep. And this is the chunk algorithm generation. As you can see, it generates around the player, not okay, I'm done. But as you can see, it generates around the player in sort of more of a spiral looking shape instead of just a grid, which is very nice. So up till this point, I wouldn't even call our terrain generation. Like, what is it generating? It's just sine and cosine mapped together. So instead, what we need to do is to implement some Perlin noise. And I ended up using a library for my Perlin noise generator. Although it is not that complicated, it is pretty complicated to get it working good. And if you don't know what Perlin noise is, it's pretty much just a randomated sinusoidal wave. And this is all the code that it took me to do that. And like all first attempts, the first one does not go very smoothly. It's far too flat. The next attempt is far too mountainous, very rugged. And the next attempt was, well, that is looking pretty good. And this is starting to look like version 1.0 Minecraft at this point. And well, this is fun and games and all, and it's looking pretty good, but the actual software side of things is very ugly. If we zoom out and look at how much RAM is taking, the game is taking up, it's an absolute atrocity. Basically, all I was doing wrong was that I was storing the block vertices in all of the chunk data. And if you're a programmer, you know why this is a bad idea, because the vertices do not move and they're all the same for every single block, so there is no reason to store them. And with that little conundrum out of the way, we are drawing double the map for less than half of the original memory. I did not mean to end that on the bass drop. And now we have a new problem where the game is lagging whenever new chunks are trying to be generated. And the simple reason for that being is that I'm not threading the chunk generation, I'm just doing it every other frame. So, well, the solution to that being that I would have to add threading. And using only this code, well, the world generation is now threaded. And as you can see here, the world generation is A, faster, and B, less laggy. And I even added these little sand dunes, which will hopefully be filled with water in the upcoming future. So the last optimization slash the last trick up my sleeve really is to simply load chunks that are only in front of the player, i.e. if chunks are behind the player, don't load them. And we get this by getting the viewport and calculating whether a chunk is in front of them, and if it is, well then we load them. And what you're looking at here is a more extreme version of that. This is what the game actually looks like with that optimization in place.
For part 2 of this, I want to hopefully cover some biomes and structures, trees, stuff like that. Thank you if you watched this all. I will leave the GitHub. I will leave some code in my GitHub in this video in the description. If anybody wants to check it out, remember to like, comment, subscribe, share, and give me your credit card information. Also, if you're a experienced programmer, if you would like to suggest some ideas slash better things on any of my designs, I would be very appreciative. Thank you.